What we're doing today is looking at all the different kinds of factors. You see the sheet that you have in front of you. 40 questions on it. They're all for homework. 40 questions, but you're going to get a chance to do a lot of them today, and then you have a long weekend, so you got lots of time, and the more you practice, the better you will be. And that's all the different kinds of stuff all mixed up. There's a few harder ones, but most of them are fairly straightforward. And so it's just a matter of identifying the type and then carrying out that type of factoring. So here are the types of factoring that we've looked at so far. Okay? Common factor. I'll put this back up after. I really want you to listen. So if you're writing and you can't listen, then maybe you can write it down later. Okay? But because I really want you to listen and be paying attention to this. So the first thing we looked at was common factoring. Now, common factoring is that one where you can always common factor anything, right? Like anything might have a common factor in it. And you always try to common factor first because that will make our next job way easier. We'll see an example of that today. But it'll work for any number of terms. Always look first, and don't forget numbers and variables. Some people might get a little stuck just looking at the numbers. Like if everything's a multiple of a 2 or multiple of 3. But if there's a variable in there like an a or an x that you can divide out of everything, then you got to do that as well. And for a lot of the questions today and moving forward, if you don't see the common factor, you can't do the rest of it. Like you have to common factor first. And then you can continue. Okay, so really important, get used to looking for common factors first. And it's any number of terms. And then we did factor by grouping, and I don't think there's any factor by grouping questions on this sheet, but we'll see some next week. And that is when you have 4 terms. If I was looking at something that was 4 terms, it might be common factor, because common factor is any number of terms, or it might be factor by grouping, which we look for factors of the first 2 and factors of the second 2 type thing. Okay? And then we did simple trinomials, which notice it has 3 terms. Why? Tricycle, triangle. What else is tri? Trilingual. Yeah. It means you are fluent in 3 languages. Very nice. Right? It means 3 of something. So trinomial is a 3-term polynomial, right? And how do I know it's simple compared to complex? X squared coefficient is a 1. Look at complex trinomial. It's still a trinomial, so it's still got 3 terms. X squared coefficient is not 1. It's 2 or 3 or 4 or 5 or 6 or something, anything else. Then it's a complex trinomial. See how important it is that you count the number of terms. Like that's one of the biggest indicators of what's going on is how many terms it has. If I have a 4-term question, it's not a trinomial, right? So it's not simple trinomial or complex trinomial because it's not a trinomial. Okay, then we did a couple of special products. So a difference of squares, again, it has 2 terms. So again, the number of terms is telling us what to look for, where to start, what to do. And in this case, I could have something that has 2 terms that's just a common factor. But if both terms are perfect squares and there's a minus sign between them, then it's a difference of squares. It could be a common factor question and a difference of squares. It could be one or the other or both. X squared minus 9. The only time when I say minus sign between them, if I rewrote this and said minus 9 plus x squared, that's a difference of squares that's written in the wrong way. Still a difference of squares. I would rewrite that properly, like the line above it with the minus sign between them, and then factor it like a difference of squares. That's what I would do. So that's is a difference of squares, but the minus sign isn't technically between the terms. But one of them is negative, one of them is positive, so it checks out. And then the last thing, this is a little bit trickier, but perfect square trinomials are their special product. It's a trinomial, so it has 3 terms, it's a special case of either a simple trinomial or a complex trinomial. The first and the third terms have to both be perfect squares, and this is a tricky part. The middle term is the square root of the first term times the square root of the third term times 2. Right? So what does that look like? What's the square root of the first term? X. What's the square root of the last term?
5.
X times 5 times 2 is 10. So this is a perfect square trinomial. Does that make sense? Yep.
Do we have to write it like x plus 5 squared?
You don't have to. And the nice thing about these is they can be factored like a simple trinomial or a complex trinomial. I could say two numbers that add to 10 and multiply to 25, and that will work. So you can do it that way. It's absolutely fine. But the connection and seeing what a perfect square trinomial is will be important later on. So it's something that every time, if I was factoring that other way, and I noticed that, oh, it's x plus 5 and x plus 5, it's the same thing, I'd be like, that was a perfect square trinomial. I didn't notice before, but I'm at least noticing now that I'm done. Like I would try to force myself to make that connection. Here's an interesting question. We didn't do these. We'll do some a little bit next week. Usually I do them, but we skipped over them. Don't yell out the answer, please. So K is a number, but we don't know what. What number does K have to be to make this a perfect square trinomial? What do you think? What number would it have to be? If I said I'll give you $1 million to guess, could you come up with a guess? Jacob, could you come up with a guess for $1 million? I'm not giving you $1 million. That is not a deal. You don't have 20 witnesses in here. Could you come up with a guess? What do you think, Dylan?
I think it's 6.
6. How many people thought it was 6? Awesome. You can go to the main office and get your $1 million at the end of the day. They'll give it to you, trust me. Okay, so 6, right? K is 6. Why? Because the square root of 9 is 3. Square root of x squared is x. 3 times x times 2 is 6. Here's a harder one. I'm just going to let you think about it. 4x squared plus kx plus 36. What would k be? Don't say it. I'm not even going to tell you right now. I want you to think about it. What would k be? Okay, so anyway, our summary is count the number of terms, look at things like the x squared coefficient, look at things like if there's two terms, is there a minus sign between them? Look at these different kinds of things to identify what kind of a question it is. So I'm going to have you factor all of these in a minute, but before we do that, we're going to talk about what each one is. What would you say this kind of a question is? Like, how would you factor this? What kind of factoring question is this? Common factor? Why do you say common factor? Nice. Very good. Absolutely. It is a common factor. What else do you think it might have been? Was anybody thinking a trinomial of some kind? There's 3 terms. Complex trinomial. Right? Because it's not a 1. But there's, like, I don't know for sure. I'm going to common factor this and see what's left. But in my mind, that doesn't really look like a complex trinomial or simple trinomial, because there's all kinds of other junk in there, like m squared and n to the 4th, and every term has m and n. That looks more to me like just a straightforward common factor question. Okay, what about B? Don't yell it out, please. What kind of factoring question is this one? Alan? How do you know that?
X is 1.
Simple trinomial, and the x squared coefficient is 1. That's why it is simple. That's straightforward, isn't it? Is that easy? Everybody get that? Compare that to this one. What does C look like? It looks like complex. Why? Very good. But then we're going to look again, and what else are we going to notice, Liam? There's a common factor. And when I common factor it out, maybe it's no longer a complex trinomial. We have to wait and see, but maybe, maybe not, right? See how this works? Like every one of these is its own little individual puzzle. It does. The instructions will not tell you what each type is. This one's a simple, factor it like that. This one's complex, factor it like that. Won't tell you. It's just going to say factor, you have to decide. With simple, two numbers that add to this, multiply to this. With complex, you're dancing. Difference of squares, that's a different kind of factoring. You just got to know the pattern. See how all these are a little bit different.
On the test, when you give any questions, you just give us a question like that and ask what
I
type it is.
don't usually do that, but I could. Might be kind of an interesting question to ask. Yeah, could happen. Sure, anything's possible. Al?
In the common factoring lesson,
Yep.
is it actually called the multiplying column?
No, it was after that. Should have been called like common factoring, factor by grouping.
Special products after that.
Well, like not directly after, but after. So. Okay, D. What do you think about D? What kind of question is that? Well, let's count the terms. It can everything can be common factor, so it might be common factoring. Does it have 4 terms? No, so it's not factored by grouping. Does it have 2 terms? No, so it's not a difference of squares. 3 terms is trinomial, so which one is it, simple or complex? Rachel, what do you think? What kind of trinomial is that? How do you know? Right, x squared term is 5x squared, not 1x squared. Good, yep. Okay, whoop. E. What kind of trinomial is E? Ziggy, what do you think?
Complex trinomial.
Because? Good. What kind of trinomial is F? Liam? It has a common factor, good spot. And after you divide out 4, what do you think is going to be left? Still a complex trinomial, thank you, very good. Right, because they're still going to have, see how you can put this stuff together? You don't have to be able to see it ahead, but, okay. What kind of trinomial is G? Riley? I said, what kind of trinomial is it? You're supposed to fall for my trick and say it's a complex because it's 9a. You're right, exactly, difference of squares. Because there's 2 terms, and everything's a perfect square, and there's a minus sign between them. Good. Didn't fall for my trick. What kind of trinomial is this one? It's not a trinomial, it's only got 2 terms. Same trick. Okay, that didn't work either. What kind of factoring question is it? Is it a difference of squares? Why not? 8 is not a perfect square. Very nice. Jaden? It does have a common factor. What happens? I'm going to help you with this one. 2, 4 minus 25m squared. And look at that. Now it is a difference of squares. They're backwards, but that's okay. Everything's a perfect square. There's 2 of them, minus sign between them. So I can do one more step for that question. Notice how I had the common factor first before I can do any other kind of factoring. Any questions?
Yesterday on the homework, there was this question. The answer say it was like in brackets 9x minus 12 and then 9x plus 1.
Yeah.
Would you still simplify it? Like,
Oh, yeah, because there's a common factor in there. Absolutely, you should. Yeah. Was that in the textbook? Huh. Weird. Yeah, for sure. Okay. Copy down these 4 questions. Liam.
The square root of 25m squared is that 25m or 5m?
5m. Copy down these 4 questions. Leave a little space to solve them.